Graphing helps us visualize the solution to the system of linear equation. But solving by graphing is not always fast and accurate, especially if the solution is not an integers. Oftentimes, graphs are used to approximate the solution to the given system. To obtain the exact value of the solution, we will use the algebraic method. In this video, I will teach you the other two methods in solving system of linear equation, that is, by substitution method versus the elimination method. And it's up to you to decide which of the two methods you are going to use in solving systems of linear equation, because both of them will lead us to the same solution. If you are new to this channel, kindly hit the subscribe button and the notification bell, and I promise that I will journey with you in learning math lesson in an easy way. Solving systems of linear equations by substitution method versus the elimination method. So in this video, we are going to compare the two methods in solving systems of linear equations, and it's up to you to decide because both of them will give us the same solution. These are the steps in solving the systems of linear equation by substitution method. First, you're going to solve one of the equations by either in terms of x or y. Step number 2, substitute the expression obtained in step 1 into the other equation. Then solve the resulting equation in one variable. Then find the value of the other variable by substituting the solution found in step 3 into any of the equations containing both variables, and check the solutions in the original equation. These are the steps in solving the systems of linear equation by elimination method. First, you're going to decide which variable you want to eliminate. Second, you're going to multiply one or both equations by an appropriate constant so that the variable that you want to eliminate becomes additive inverse of each other. Third, you're going to add the resulting equations and solve the equation obtained in step number 3. Substitute the value of the variable obtained in step number 4 into one of the original equations and solve for the other variable, and check the solutions in both original equations. Let's have example number 1. Equation number 1, x minus y is equal to 4. Equation number 2, x plus y is equal to 6. So we will solve this problem using substitution method. These are the steps. In solving system of linear equation, we are going to decide which of the equations that you are going to solve in terms of the other variable. So in this case, I choose to solve equation number 1 in terms of x. We will isolate the term with x at the left side of the equations by addition property of equality. So it's going to be positive y plus 4. Then we just copy the second equation. Using the equation number 2, since x is equal to y plus 4, in equation number 2, instead of writing x, we will substitute it by y plus 4. Then we just copy positive y equals negative 6. Notice, in this equation, the variable present is only y. So that's the very purpose of substitution property, so that only one variable will appear in the equation. So simplify by multiplying 1. So this is y plus 4. We just copy positive y is equal to negative 6. Further simplification, so 1y plus 1y is equal to 2y. Then is equal to negative 6. Transpose positive 4 to the right side of the equation by addition property of equality. So this will be negative 4. Simplify, negative 6 minus 4 is negative 10. Divide both sides by 2, the coefficient of y. So negative 10 divided by 2 is negative 5. So we have now the value of y. So we are now going to solve for the value of x. In solving for the value of x, you can choose either equation 1 or equation 2. But in this case, we will make use of the equation 2. X plus y is equal to negative 6. Copy x plus the value of y, negative 5, is equal to negative 6. Positive times negative, that would be negative. So we just copy negative 6. Transpose negative 5 to the right side, so that would become positive 5. So negative 6 plus 5 would be negative 1. So therefore, the solution would be negative 1 and negative 5. For us to check whether this value of x and y is really the solution to the system, so we have to check. So to check, we will go back to the original given equation. So the solution is -1 and -5. In equation number 1, x minus y is equal to 4. If our x is -1, substitute, then minus the y is -5 is equal to 4. Simplify, this is -1. So negative times negative becomes +5 is equal to 4. Then -1 plus 5 is equal to +4. And this is equal to +4. So notice that this solution satisfies the first equation. Let's try to check it in the equation number 2. X plus y is equal to -6. Substitute the given value. The x is -1 plus the y is -5. Further simplification, so this is -1. Positive times negative is -5 is equal to -6. -1 minus 5. So we just add the two numbers. So this is -6. And that is equal to -6. Notice that this value of x and y satisfy both equation 1 and equation 2. So therefore, the solution to this system is -1 and -5. So in other words, the graph of equation number 1 and the graph of equation number 2 will intersect at the point -1 and -5. Let's do this by elimination method. So these are the steps in solving systems of linear equation by the elimination method. So in this case, we are going to decide which of the two variables that we are going to eliminate. So make sure that the coefficient of the variable that you want to eliminate must be equal and their sign must be opposite to each other, or the terms must be additive inverse of each other. So in this case, we will eliminate y. So how are we going to eliminate? We will add the two equations. So by adding the two equations, so this y will be cancelled out. Since they are additive inverse, so their sum is equal to 0. So what we're going to add now is the x, and 4 plus -6. So x plus x would be 2x. Then +4 plus -6. So they are opposite signs, subtract. So 6 minus 4 is 2. The sign is -2. So the resulting equation now would be 2x is equal to -2. Solve for x, divide both sides by 2, the coefficient of x, so x would be -1. And in solving for the value of y, we can make use either equation 1 or equation 2. But in this case, we will use equation 2. So our equation 2 is x plus y is equal to -6. And substitute the value of x, which is -1, then plus y is equal to -6. So -1 plus y is equal to -6. Then by addition property of equality, transpose -1 to the right side of the equation. So that would be +1. Further simplification, so -6 plus y is -5. So the solution is -1 and -5. So indeed, whether it is substitution or elimination method, the solution to the system is the same. We will not anymore check this one because we already checked this solution from the previous slide. Example number 2. Solve the system 3x minus 2y is equal to 12 and x minus 2y is equal to 6. Now, by substitution method, we will express one of its equation in terms of the other. So, this is another technique. Since the coefficient of x is +1, so I will solve this equation in terms of x. So, what I'm going to do is we'll just copy the equation number 1. And in equation number 2, we will solve this one in terms of x. So, x be equal to transpose -2y to the right side. So, that would be +2y. So, by substitution property, so we will substitute this expression 2y plus 6 to the variable x in the first equation. So, 3 times 2y plus 6 minus 2y, and we just copy 12. Further simplification, distributive property, 3 times 2y is 6y. Then 3 times 6 is +18. Then minus 2y is equal to 12. 6y and 2y are like terms. 6y minus 2y is +4y. Then transpose 18 to the right side. So that would be negative 18. Further simplification for y. So 12 minus 18 is negative 6. Divide both sides by 4. So this is negative 6 over 4, or in lowest term, this is negative 3 over 2. So we already have now the value of y, so let's solve for the value of x. So again, you can choose either equation 1 or equation 2, but we will use equation 2. So our equation 2 is x minus 2y is equal to 6. So substitute, so x minus 2, the value of y is negative 3 over 2, then is equal to 6. So notice this is the numerator and the denominator has a common factor, so you can strike this out. So what is left is negative 1. So negative times negative 3, so that would be positive 3. We just copy 6 and x. So further simplification by addition property of equality, so this is 6 minus 3. Then 6 minus 3 is 3. So therefore, the solution is 3 and negative 3 over 2. So we will solve the same system by elimination method. So the given system, so in this case, we're going to decide which of the variable that we are going to eliminate. Notice that y have the same coefficients. However, these two are on the same signs. If you want to eliminate y, we just copy the first equation. But in equation number 2, we will multiply it by negative 1 so that this term will become positive. This would be negative 1 times x is negative x. Negative 1 times negative 2y is positive 2y is equal to negative 1 times 6, negative 6. We are now ready to eliminate the variable, so we will add the two equations. So by adding the two equations, these two additive inverse will be cancelled out. So what is left is these terms. 3x plus negative x, 2x. Then 12 plus negative 6 is positive 6. Divide both sides by 2 to solve for x, so the x is equal to 3. Solve for y, use equation 2. So our equation 2 is x minus 2y is equal to 6. So our x is equal to 3, substitute, minus 2y is equal to 6. So negative 2y is equal to 6, transpose 3 to the other side, so that would become negative 3. Then 6 minus 3 is 3. Then divide both sides by negative 2, the coefficient of y. So our y is equal to negative 3 over 2. So indeed, the solution is the same, which is 3 and negative 3 over 2. So to check that our solution is correct, so we have to verify it using the two equations. Our equation 1, 3x minus 2y is equal to 12. Substitute, so 3 times 3, the value of x minus 2 times the value of y, negative 3 over 2 is equal to 12. So 3 times 3 is 9. So negative 2 times negative 3 over 2, cancel out 2. So that would be positive 3. And this is equal to 12. So 9 plus 3 is equal to 12. So equation number 1 is satisfied. Let's try to verify equation number 2. So the value of x is 3 minus 2. The value of y, negative 3 over 2 is equal to 6. So this is 3, copy 3. So cancel out 2. So negative 1 times negative 3 is positive 3 is equal to 6. So 3 plus 3 is equal to 6. So both equations are satisfied. So therefore, the solution to the given system is 3 and negative 3 over 2. Let's try to solve example number 3. So the system, 3x plus 4y is equal to 4. Equation number 2, x minus 2y is equal to 2. So by substitution method, so 3x plus 4y is equal to 4. X minus 2y is equal to 2. So in this case, we will solve the equation number 2 in terms of x. So we just copy equation number 1. And equation number 2 would be x transpose negative 2y to the right side. So that would become positive 2y plus 2. Then substitute this expression 2y plus 2x in equation number 1. So therefore, our equation would be 3 times 2y plus 2 plus 4y is equal to 4. So notice that only variable y appears in this equation. Simplify by distributive. Distribute. So 3 times 2y is 6y. 3 times 2 is positive 6. 4y is equal to 4. So 6y plus 4y is 10y. Copy 4. Transpose positive 6 to the right side of the equation. So that would be negative 6. So 10y is equal to negative 2. Divide both sides by positive 10. So this would be y is equal to negative 2 over 10. In lowest term, negative 1 over 5. Solve for x, use equation number 2. Substitute the value of y, which is negative 1 over 5. So negative 2 times negative 1 over 5 is positive 2 over 5, and that is equal to 2. So transpose positive 2 over 5 to the right side, so that would be negative 2 over 5. So x is equal to, so the LCD of 1 and 5 is 5. So cross multiply, 2 times 5 is 10. Then minus, this is 1. So 2 times 1 is 2. Further simplification, 10 minus 2 is 8. Then we just copy 5. So the value of x is 8 over 5. So therefore, the solution is 8 over 5 and negative 1 over 5. Solve this system by elimination method. So as what we all knew, that we are going to decide which of the variable we are going to eliminate. So in this case, we will eliminate y. So we just copy the equation number 1 and we are going to eliminate y. So the coefficient of y in the first equation is 4. The coefficient of y of the second equation is 2. So we have to make this 2 would be additive inverse. So we have to multiply the equation number 2 by positive 2. So further simplification, copy this equation, then distribute, multiply. So 2 times x is 2x. Then 2 times negative 2y is negative 4y. Then 2 times 2 is 4. Add the two equations since they are already additive inverse, so we can cancel them out. So what is left is 3x plus 2x, so that would be 5x. Then 4 plus 4 is 8. Divide both sides by 5, so the value of x is 8 over 5. Solve for y, use equation number 2. So our equation 2 is x minus 2y is equal to 2. So our x is 8 over 5, then minus 2y is equal to 2. Then transpose. So this is negative 2y is equal to 2 minus 8 over 5. So negative 2y is equal to, so the LCD is 5. So cross multiply, 2 times 5 is 10. Then minus 8 times 1 is 8. So this would be 10 minus 8 all over 5. Simplify 2 over 5. To get rid of the fraction, multiply the whole equation by the LCD. The LCD is 5. So multiply each term by 5. So 5 times negative 2y is equal to 5 times 2 over 5. So 5 times negative 2y is negative 10y. So cancel out 5. This would be 2. Divide both sides by negative 10. So this would be negative 2 over 10 or negative 1 over 5. So therefore, the solution is 8 over 5 and negative 1 over 5. So as you can see, both methods give us the same solution. So let's try to solve example number 4. Solve the system 3x plus y is equal to 2. Equation number 2, 3x plus y is equal to 4. So by substitution, we will express the first equation in terms of y because the coefficient is positive 1 already. So this would be y is equal to negative 3x plus 2. Then substitute this expression to y in the second equation. So our second equation is 3x plus y is equal to 4. Then instead of writing y, substitute it by negative 3x plus 2. So further simplification, we just copy 3x. So this is negative 3x plus 2 is equal to 4. So 3x minus 3x is 0. Then plus 2 is equal to 4. Then 0 plus 2 is equal to 2. And that would be equal to 4. So notice that in this case, since the x terms drop out, and the resulting equation is a false equation, therefore the system is inconsistent. False equation because 2 is not equal to 4. So therefore, the system has no solution. So if we graph this equation, the graph is a parallel lines. So let's try example number 5. solve the system x plus 3y is equal to 2 and 3x plus 9y is equal to 6. We solve this equation by elimination method. So if we want to eliminate y, we have to multiply the equation number 1 by negative 3. Negative 3 times x is negative 3x. Negative 3 times positive 3y is negative 9y. The negative 3 times 2 is negative 6. We just copy equation number 2. So we'll add the two equations. As you can see, the variable x will be cancelled out. The second variable, the variable y is also cancelled out. Then the constant, negative 6 plus 6, our additive inverse will also be cancelled out. So therefore, the answer is 0 is equal to 0. This is a true equation. 0 is equal to 0, but the x terms and the y terms were dropped out. In this case, the system is consistent and the equations are dependent. So system consistent, the equations are dependent. So this is the graph of the coinciding lines, which means that there has infinitely many solutions. So the solution to this system is a coordinate x and y such that x plus 3y is equal to 2. Or it can be the second equation, 3x plus 9y is equal to 6.
If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share our videos so that I will be able to help you learn math lessons and concepts in an easy way. See you in our next video. Thank you for watching.